the final goal before we move into sine, cosine, and all the functions that we talked about in the intro is to solve the rest of the special points on the unit circle, as I showed a minute ago, and trying to understand the rest of these points because we talked way too much about one, 0, 0, 1, negative 0. But what about some of these other points that we can see on the unit circle? Why do these make sense? And what are their respective terminal distances as well? But if we consider, say, the halfway point from the initial point 1 comma 0 and the terminal point on the top at 0 comma 1, there's a point right smack dab in the middle. And we looked at this point a minute ago, which was root 2 over 2 comma root 2 over 2, and I mentioned that it has to be in the middle because it's exactly the same amount to the right as it is up. But if we kind of consider this 45-degree halfway point, we could think about, well, what is this equation line and where does it intersect the point on the circle? But a line which goes directly in the middle, where it has uh, in the halfway point, must have the condition that x is equal to y, because as we saw, root 2 over 2, root 2 over 2, both of those were equal when we plugged them into the unit circle equation, and it worked out. But essentially, if we plug in y equal x into the unit circle equation, that's what we're going to get is that very fundamental point. So let's just do that as an exercise, um, even though we kind of already did it. Sorry, my dog is begging me next to me, so I'll try to not be distracted by this. Stop pawing me. Go on, go on, go on. Ah, goodness. All right. Get my whiteboard going. All right. So that halfway point, that's what we're working on. So if we have the unit circle x squared plus y squared equal 1, this is our equation. And what I was saying is that if we wanted to find the halfway point, it must be within the equation y is equal to x. So that's a 45-degree equation of a line with slope 1, intercept 0. Linear equation. Anyways, that would give us x is equal to y. So what I could do is basically x and y are interchangeable or the same thing. I could plug in y and x. Y is equal to x. So basically x squared plus x squared must be equal to 1 at that specific location, or that would give us 2x squared is equal to 1. Dividing by 2 would leave us with x squared is equal to 1 half, which is exactly the math we did a minute ago, and square rooting both sides would leave us with x is equal to plus or minus the square root of 1 half, which we already did is root 2 over 2 in a previous video, but essentially this would give us the coordinate on the unit circle uh, where the halfway point for that terminal point right here. Um, and also, since x is equal to y, both of those would have to be same. So in quadrant 1, it would be the point where they were both positive. But notice that actually there's another point down there that would be on that line as well, which would be where both root 2 over 2's would be negative in quadrant 3. So there's technically two solutions to this problem that we're doing. Go away, pest. Dog, come on, come on, come on, go on. Anyways, so what is my point here? This is another very special point on the unit circle, terminal point on the unit circle, and it's exactly halfway from the start to the top. And another thing is we could figure out what is the distance from the starting point to that point, because it's halfway. Because the distance from start to the top was pi over 2, because that was 1/4 of the circle. And so half of that would be pi over 4. And that is the corresponding terminal distance from initial to halfway. Sorry, I wrote pi over 2, I meant pi over 4, and I said pi over 4. Distractions, dogs, and bones and stuff, so I'm going to try to stay focused. But nonetheless, this is another very special point. And the unit circle itself, that diagram with the full table of all values, um, is the point I'm trying to get here is that all of these points make sense. They're derived and they're fundamental points. Dude, you are way distracting. But what I wanted to do is leave it at here, and there's a few other points, like notice root 3 over 2 comma 1 half comma root 3 over 2. And we haven't quite talked about these. We're actually going to talk about these in a later section because it's a little bit easier to prove those later. But basically, notice that the points here on the unit circle sheet. Also, this is something that we're going to have a quiz on the unit circle, and on the test, I'm going to allow you to use your quiz answers on there because this is something you do need to memorize. But for now, the point of a lot of this is to talk about why does this all make sense. But um, really, the fundamental definition is, we have the starting point along the unit circle. Moving around a full 2 pi gets us back to the start. And moving to other various points, like say, for example, the left side, distance pi, the top, distance pi over 2, all of those points have a specific related terminal distance to get there. And that's what the unit circle is conveying. That's what all this information is. Like for example, root 2 over 2, I can see that pi over 4 is next to it, and that's what this is indicating to me when I'm reading it. Is this point on the unit circle is pi over 4, and that again tells me the distance from initial to terminal at that location. And like for these other locations, say for example, 1 half comma root 3 over 2, its terminal distance is pi over 3. This one is pi over 6. And we're going to review some of these, more of these later. But like say for example, we're talking about some of these other points like 3 pi over 4 over here. They're all combinations of these fundamental points in the first quadrant. Because let me draw on this here for a second. If I imagine, like, once I know this point that I just deriven, whatever, the one we just figured out, which was halfway to the top, was pi over 4. Well, now notice that this point over here is also another halfway point. So I could kind of use some common sense to say, well, if I were to go halfway or if I were to go all the way to the top, then another halfway here, that would be a combination of, well, pi over 2 to get to the top, and then pi over 4 to go the remaining distance. So if I take pi over 2 plus pi over 4, that would get me all the way to this point. Which notice it's the same values as the point we just figured out, but it's instead of being right root 2 over 2 up root 2 over 2, it's left root 2 over 2 up root 2 over 2 due to symmetry, due to the reflective nature of the unit circle. Um, but I was almost done. But basically, if I add pi over 4 plus pi over 2, again, needing a common denominator there, that would be 2 pi over 4 plus pi over 4. It would give me 3 pi over 4. And anyways, this chart is there to give us all the information for all of these special points on the unit all at once. And in the next few videos, we're going to practice evaluating trigonometric functions. It's very useful to have this uh, resource next to you when you're working on it. It makes it way easier to understand how trigonometric functions work. The ultimate end goal is to have this memorized. And I'll give you some tips and tricks later about how do I memorize it, because it's real. There's a lot of patterns within the unit circle. I mean, it is a circle, so there's a lot of repetition. But that's the end goal for now. I want it to be kind of clear. What is this? And really, all of these points make sense. It's all just a physical points and distances. They're all sensible because it's built from a circle